Welcome students to this lecture where we will find out the downsides in activities performed in each phase of the software lifecycle that we saw in previous lecture. Starting with, when there are multiple teams writing their set of codes in their own branches, the first problem comes out while integrating the code. Let me explain how. Now to integrate and build the code, we saw codes from different teams is sent to build and integration team. Now since build and integration team knows very little about this code, the developers from each team, like front-end and back-end team in our case, joins and sits with the build and integration team to help them in code integration. Now with this conventional software development practice, usually what developers do while writing the code is, they keep on adding the code in their local machines and do not check in the code frequently to repo for weeks or even months. It is more than possible that multiple developers would be working on the same code file parallelly in their own systems. So do you see the problem here? After few weeks or month of development, developer himself would be unable to recognize his own code, from where it starts and where it ends. He himself can get confused in his own codes, and the worst case is when he leaves the organization in between. If a proper handover of codes is not done, then all of his weeks of code development needs to be understood by some new developer and then integrated into the final code. In short, you can say that when multiple gigantic codes from different teams come to build and integration team, the integration of such codes become a total mess. Moreover, since this integration is itself a manual and lengthy task, so it takes a good amount of time from several days to weeks to integrate just one phase of code. Imagine how frequent releases you can make when for a smallest of change takes this much time. Unable to add new features in this fast moving and digital world is of course considered as inefficiency. In nutshell, if I would say, the first drawback is that it takes huge amount of time, efforts and human resources to integrate the code. And yes, again, don't forget that to integrate code, it requires developers from all the teams to sit and join, which definitely wastes their development hours. Moving ahead, let's just say the code has been integrated successfully, though after several days. Now suppose after integration, the integrated code does not work. A red flag is raised from build and integration team, which means the code requires more time for developers to work. The fun part here is, since the integration defect surfaces after a long time, at this moment it becomes a little difficult for developers to recall that huge code which they would have written long back and then correct it. So the takeaway is, with conventional work culture, the integration defects take time to get on surface and so is its rectification. Next problem is in this area, the operational area. So by somehow, after n number of iterations, your build package is ready for deployment and is handed over to the operations team with a requirement note, which is nothing but a list of instructions and steps required to run the application. To deploy that software package onto server, the operations team first have to read those instructions, prepare the appropriate environment accordingly, and then deploy that package onto a test server or further onto production server according to those instructions. Now guys, this manual reading and implementing method is highly error prone, as there could be miscommunication, misunderstanding gap anywhere in reading and deploying those instructions. The operation team is a human only and to err is human. So you can conclude this as a drawback that this process is highly error prone due to miscommunication and misunderstanding in understanding the documents. Next is, now suppose that software package has been successfully created and is deployed on the testing environment for quality assurance and other testing. At this stage, when the QA team finds out any functional defects in the package, they communicate those errors to the developers and developers start reworking on that code again. After it, once corrected, that new code has to again go through this long time and effort consuming process for the next review. So the downside here is the long feedback cycle. It takes a lot many days for the developer to get notified about the functional defects in the code. Ideally, developers should be notified about these such defects as early as possible. Now, without pointing out many other small drawbacks, one last major drawback I would like to mention here is the lack of streamlined automation. Like I have already mentioned, that whatever the outcomes you get from a phase, it has to be manually taken to the next phase. There are no standard defines as in how to pass on the code to business and integration team, no templates on the documentation to be provided to operations team, no pipelines, no best practices defined. Whatever suits them best, teams are following that path to carry out those activities. and also there is lot of room for automation in this lifecycle. Okay, so guys, these are some of the major drawbacks of developing a software with conventional methodologies. When clubbed, these drawbacks make the entire cycle cumbersome and time consuming. In the next lecture, we will see how by adding CI/CD into your work culture can help software development eliminating these drawbacks. See you in the next class.